Hello students, welcome to the IMS Gate Academy. How are you all? Just reply in the chat box and please let me know how many of you are here. So as you know that we had started this series Gate Score Booster a couple of days back, and we have seen a quite good response from the student side. Okay, so Shubhakar, good evening Shubhakar. So yeah, you are from EE and IN, just let me know you are from EE and IN. So yeah, as you all know, the Gate Score Booster is basically meant for the student to boost the marks in the Gate exam. Okay, suppose if you're suppose before attending this particular session, if your marks would be like let me say 50, then after this session, definitely your marks is going to be enhanced by 20 to 30 marks. It is my guarantee. Okay, so yep, I am asking about from which stream you are belong, Shubhakar. You are from EE and or from IN. Alright, so that is basically what the Gate Score Booster means. So I am here, I am a Nikhil Gaurav. Basically I am a mentor in IMS Gate Academy, and I will be taking care for the electrical machine and the measurement. Alright, so this particular session is going to be the part 1 of the electrical machine, in which we will going to cover the transformer as well as your induction machine. And my dear friend, whatever question I have taken here now, if you are going to attend the live session or if you are going to be with me throughout the session, definitely you will going to see a drastic change in yourself. And you will going to feel a confident in yourself, and mark my word, after the session, pick the gate question back and try to solve, or try to pick any question, and 100% sure that you will going to solve every question of the electrical machine. It is my 100% guarantee. Okay, but for that I want to have a request from all of your side that please be ready with your pen and paper as well as basically the copy, so that whatever question we are going to have in the screen, you will be able to solve it in a rough manner. Okay, so I will going to display the question, and after that I will provide you some time like 1 minute, 2 minutes for the particular question, so that you can going to try those particular question, and if you are able to solve, well and good. Otherwise after those time I will going to start the solution. You will come to know that in which area or in what point you have did the mistakes. Okay, so do not get worry about the question if you are not able to solve. I am here to help you out, and definitely we will going to learn in such a manner that you have never ever imagined. Alright, so guys, please do share the session link with your friends so that they may also going to come and join in a live manner, and definitely we will going to have the wonderful session over here. Okay, so guys, please do share, and also do not forget to mark your attendance by hitting the like button. Okay, so shall we start? Okay, so before that, let me go to the slide in which you will going to see what are the important topics that we are going to have from the transformer for EE and IN. This particular topic are important because if you see the past 10 to 15 years of question from the electrical machine, from the transformer, basically they were asking the question from this particular area. Okay, so we need to focus more on this. As you know that the electrical machine is very vast, you are having a lot of things, you are having a lot of laws, lot of formulas, but my dear friend, mark my word, you are going to have only 50% of the overall syllabus. Like if you are having the knowledge of the 50% of the particular topic now, you can get full marks in the electrical machine, and it is my experience. Okay, so here you need to focus mainly on those important topics which I have already written over here. So please master on this, and definitely you can crack any question from the transformer. Okay, so let us start, and I am hoping that you are ready with your copy and the pen. Alright, so here comes the question number first. Let me give you the time. Okay, So let me give you 2 minute time for this, not more than that, and after that I will start the solution. Okay. So your time starts now. Electrical, thanks a lot, sir. Please take more lecture, sir. Definitely electrical. I will going to take like this is a part 1. Part 2 I will going to take on tomorrow, and definitely you will going to have a great experience. Definitely you will going to see a great change in yourself. Okay, all right. So please do solve it. Please at least give a try. At least give a try. It doesn't matter at all if your answer is wrong. Here we are here to learn. Okay, definitely we will going to see the things in a different manner. Okay, so please try it once, and after that I will going to start the solution. Okay, guys, please do share the session link with a friend and colleagues, as I am seeing the very few students over here. So please do share the session link so that we will going to have a good number of strength, as well as we will going to learn from each other, isn't it? Okay. All right, 50 seconds remaining. Do it fast. What is the answer? I know most of you are going to give the correct answer for this question, but for that you need to reply in the chat box. Please do it. Yeah. Time is running out and time's up. Okay, all right. So see here, an ideal audio frequency transformer couples a 60 ohm resistive load to an electronic circuit which is represented by a constant voltage source of 5 volt in series with an internal resistance of the 240 ohm. Find the transformer turns ratio so that the maximum power transfer takes place from the source to load. So basically this question is belongs to, or it is a combination, this question is a combination of your network and the transformer. Okay. So yeah, see, here you are going to have a transformer in which the load is 60 ohm and the source is having the 5 volt in series with the 240. Now to get the maximum power transfer from the source to the load side, what should be the condition? What should be the condition? Okay. So before that, let me make the equivalent circuit for this. Okay, just a second. Let me change the color. Okay. So this is 240 ohm this is primary side, and this primary side is connected with 5 volt source, isn't it? It is a 5 volt source in series with the 240 ohm resistance, and your secondary side is having the load as 6 ohm, Done. So let me take the number of turns like this, N1 and N2. So this is your primary, this is your secondary, this is primary turns N1, this is secondary turns N2. So in the question, what I have asked, the value of turns ratio. I hope this color is visible. Okay, let me change the color, just a second. Okay. So turns ratio. And what is the definition of the turns ratio? It is a ratio of primary turns to the secondary turns, means N1 by N2. That I need to calculate for this. But when the maximum power is going to be transferred. Now if you see here, for the maximum power transfer, if you go by the network theory, if the Thevenin equivalent impedance becomes equal to the load impedance, then the power is going to be maximum. But those are applicable for the electrical network. So this transformer is what? Electrically isolated but magnetically coupled. So here those particular concept is not valid. So what I will going to do, I will going to refer the secondary side to the primary side. Shubhankar 4. No, Shubhankar, please check. I think you have did some calculation mistake. Please check once. Okay. So what I will do, I will going to refer the primary to the secondary side. So for that, let me move this to left hand side. Okay. Refer secondary side to primary side. Okay. So look at here. This is primary and this is secondary. So let me give you a shortcut for this. So this parameter we need to shift to the primary side. So this will act as a source, like not the voltage source. This will be your origination point or originating point, and this is your terminating point or destination, like that, source and destination. So when the impedance is going to be transferred, na? So let me take this as ZL. Okay. So when it is referred to the primary side, it will become ZL dash. So this is equal to actual value times destination number of turns. What is that? N1 divided by source, which is N2 number of turns. So this is a shortcut. This is only valid for the impedance. Okay. So actual value into destination turns divided by source turns ka whole square. Okay. So when you shift this to this side, your equivalent circuit will be like this. This is 240 ohm. Is it clear, everyone? 5 volt. Okay. And after that, this is referred here. Sorry. Like this. So this is your ZL dash. So what is ZL dash value? So your ZL dash is equal to actual value is 6 into N1 by N2, which is nothing but the turns ratio. So let me take this as small n. Okay. So this will be equal to n ka whole square, or basically 6n square. Am I clear? So n I need to calculate. So this value will become, ZL dash will become 6n square. Done, my friend. Now for maximum power transfer, one condition we require, and what is that? Your ZTH should be equal to, or it is better to write load, ZL should be equal to Z Thevenin. This is Z Thevenin or Thevenin impedance. Done. Now here ZL basically is what? ZL dash, hai na? Because you have referred to the primary side. So this is ZL dash basically. Okay, here it is ZL dash. So how to get the Thevenin impedance? Deactivate all the independent source. So here what is independent source? Voltage. So voltage is going to be short circuit, whereas the current source is going to be what? Open circuit. So we remove this one, and from here look at the number of look at the Thevenin resistance or impedance. So remove this, and this is short circuit. So what will be the Thevenin impedance? It will be only 240 ohm. It will be 240 ohm. So your Thevenin impedance is nothing but 240 ohm. Am I clear, everyone? Done. So ZL dash is what? We have somewhere written 6n square, I guess. Yeah. So 6n square is equal to 240 ohm. So from here n square is equal to 4, or n is equal to root over 4, which is nothing but 2. So this n is nothing but your turns ratio. Am I clear, Shubhakar? Is it clear? Any doubt in this? So this n is what? 2, which is given in option B. So option B is the correct option for this question. Is it clear, Shubhakar? And electrical? Alright. So let us move to the next slide. Okay. I hope this kind of question is going to help you a lot in the GATE exam. As I told you, whatever question I have come up with, those are combination of the different subject or from the different chapter, so that we are going to have the good number of flavors. Okay. Not only here, if you are going to enroll in our GATE courses now, my friend, whatever AIMTS we are having, all India mock test or the chapter test or the subject test, the same kind of or the same flavor of question we have framed, and definitely if you're going to enroll, you will going to enjoy a lot our test series. All right. Okay. So this is what our live online program. This is what our live online program for GATE 25 and 26. So see, what are the features that we are giving? We are giving 800 plus hours of the live class with live interaction, where student is going to get the chance to interact with the faculty. Okay, not personally, but in a virtual manner. Okay. Next one, this is very important: theory book, exercise book, and 30 plus years of GATE question bank, along with video solution. And 12 personalized one-to-one mentorship session, where students are going to have the chance to meet with the faculty. Whatever doubts they are having, general, technical, non-general, non-technical, they can ask to the faculty. Like how we can prepare this particular subject, how to approach the particular topic, concept, so on and so forth, like that. So in that you will going to get the 12 personalized mentorship session and 130 plus online test with video solution of mock test and many more. Got the point? So these are the features that we are giving to the students who are going to enroll for the live online. And if you want to have to counsel yourself, then you can book your counseling by clicking on the link which is given in the description box, or you can directly call on this particular number. Okay. And once this session is going to be over, then the PDF for the same is going to be shared over the Telegram group, which you can find in the description box, or you can visit to this particular link. Got the point? And you are going to get the free Y2 lecture PDF and webinar, seminar, like that. PSUs and other government job notification is very important. I know all of you are preparing for the PSUs or for the MTech and for the higher study, and for this you want the notification, isn't it? And all those you are going to get at one place in our Telegram channel. Okay, and where we are going to have the expert session on the important topic as well as daily quiz and many more. All right, so guys, I'm requesting you to please do join our Telegram group. Definitely you will going to have a good experience from our Telegram. Okay, so let us move on to the next question, the question number 2. Again, let me give you 2 minutes for this, not more than that, and after that I will going to start the solution. Okay, so your time starts now. What is the question? In the figure shown, there are two single phase transformer T1 and T2 of the turns ratio 4:1 and 2:1 connected with their primary in series across 120 volt 50 hertz source, and the dot points indicate the terminals of the corresponding polarity on the primary and the secondary side. Assume that the transformer are ideal and resistance are 5 ohm. Determine the power delivered and current drawn from the supply. So this is a supply. From here we need to calculate the power delivered by the source as well as current drawn or supplied by the source. Do it fast. Any answer? $30 remaining. Still I have not got any answer. Please do it fast. Reply in the chat box. Electrical, Shubhakar. Do it fast, do it fast. Done. Time's up. Okay. So this is a transformer where this is transformer 1 and transformer 2. Primary is connected in series. If you see or if you observe this particular secondary carefully, you will find that the secondary are connected in parallel. Okay. And one more information is given in the question that the polarity or the dots will have the same polarity or the corresponding polarity. So here let me take some notation. So since this is a transformer 1, this is your primary side and this is your secondary side of the transformer 1. So let me take the EMF here as E11, here E21, where the first number will tell you about the sides primary, and the second number is what? Your transformer 1. So therefore I have taken 1. Similarly E2, 2 is for secondary side and 1 is for transformer 1. In the same manner it will be E12 and here E22. Done. Alright, so let me change the color just a second. So here dot will be plus, here dot will be plus. Similarly here dot will be plus. So on the secondary side the dot will be plus. Now if you look at the figure carefully, just a second. Since this is a plus, so other side will be minus, na? Other side will be minus. This is plus, and this will be minus. So if you see carefully your E22 and E21, since they are connected in parallel, so therefore voltages are same. Isn't it? Am I clear? Any doubt in this? Since E21 and E22 are parallel, therefore both are same. Done. So let me take a general term for this. So E21, E22, I have taken it as a x. Done. Now, so what it means? It means that this value is x and similarly this value is x. Now, since if you take the transformer 1, you are having the turns ratio as 4:1. And what is this ratio? It is a ratio of the induced EMF. So, from transformer 1, your E11 divided by E21, this is equal to 4/1. So from here, what is E11 value, my friend? ये कितना होगा जल्दी से बताएं? It will be 4 times of E21. E21 is x. So this will be 4x. Similarly, from transformer, your E12 divided by E22, this is equal to what? What is the ratio? 2:1. So it will be 2/1. Shubhakar, 30 volt. So determine the power delivered and the current drawn from the supply. No, it is not 30 volt. X, I think you are saying about the X value. Please check. This is not a 30 volt, Subhagar. So this implies E12, this is equal to 2x. Done. Now we have got the E11 and E12. Apply the KVL in the primary loop. Apply KVL in primary loop. So what we are going to get? Minus 120 plus E11 plus E12. 480. What is 480, Subhagar? Please write the unit as well. Okay. So it will be equal to minus 120 plus 4x plus 2x. It is equal to 0. So this implies x value is equal to 20 volt. So this is what your EMF or the voltage on the on the secondary side. Okay. So this voltage is 20. Done. So what we need to calculate? We need to calculate the power delivered and the current drawn from the supply. So look at here. You are having only one resistor, which is basically a load. Sorry, sir. Oh, no issue. Please check it your calculation very carefully, and after that, please give your whatever value you are getting. Please comment in the chat box. Okay. All right. So yeah, if you see carefully, you are having one source and one load. So definitely this source is going to deliver the power to the load. So let us calculate the power in the load at the load side. So if you see carefully, this voltage is basically parallel, or this voltage is nothing but the voltage across the resistor. So power at the load side, power at the load, this will be equal to what? X square, voltage divided by resistance. So voltage is 20 square divided by resistance is 5, na, I guess. Resistance is 5. So this value becomes 80 watt. This becomes 80 watt. So this is the power which is going to be delivered to the load, because since there is no parameter which going to give you the losses, therefore this particular transformer is what? Lossless transformer. So the power delivered from the source side is basically what? Power entering into the load side. So therefore the power delivered is also 80 volt. Therefore as transformer is lossless, therefore P delivered is also equal to 80 watt. Am I clear? Any doubt in this? Is this point clear? It is very important to understand. Okay. So one part we had calculated. So let me calculate the second part, that is the current. Okay. So for the to get the supply current, we are going to have the two methods. So let me take the method 1 only for the current, only for the supply current. Method 1. Power delivered is equal to power at the load side. Now, what is the voltage here? 120. Let me take the current here as I1. Let me take the current here is I1. Okay, all right. So since your load is purely resistive, what it means? The phase angle difference between the voltage and the source is also going to be the 0 degree. Whenever the load is purely resistive, then the phase difference between the voltage and the current is 0 degree. So what it means? P delivered voltage V into I. This is the actual voltage. This is the active power or real power, which is V into I into cos phi. So V1 into I1 into cos. Angle between these two is 0 degree because of the purely resistive load, and this is equal to 80 watt. So V1 is 120, I1 we need to calculate, cos 0 is 180. So this is equal to I1. This is equal to 80 by 120 or 2 by 3 ampere. Excellent, Subhagar. Excellent. Yes, the angle is always 0 degree if the load is purely resistive. Done. So this is method 1. Let me talk about the method 2. MMF method. Okay, so look at here. Let me take the number of turns here as N11, N21, here N12, here N22. Got the point? Now, in the MMF method, what it means, the MMF supplied from the primary side is equal to the MMF delivered at the load side. So, here how many particular secondary we are having? 2 secondary. So, the MMF supplied from the source side is equal to the MMF for this transformer as well as plus MMF for this transformer. Okay. So, for the sake of simplicity, let me take the current on the secondary side. Please understand this concept very carefully. It is very important. Okay. So, let me change the color here. Okay. So, let me take the load has a current as I2. The load has a current as I2, and the current supplied from the secondary side, let it be I21, and from here I22. So, I2 is nothing but your I21 plus I22. I2 is nothing but I21 plus I22. So, can't I able to calculate this I2 value? Yes, I can able to calculate. See, this voltage is equal to resistance into current. So, X is nothing but R into I2. X is 20, I guess somewhere we have calculated 20, and R is what? 5. R is 5. So, from here I2 value will be 20 divided by 5. This is equal to 4 ampere. Got the point? Because both secondary are connected in parallel, so voltage are same. Now, if you see carefully, here voltages are same and both are connected in parallel. Therefore, that 4 ampere is basically supplied by this same ratio, because it is I2 is a combination of I21 plus I22. Since both secondary are same, so half value of the total is going to be supply, isn't it? So, from here I can get I21 which is equal to I22 which is equal to 2 ampere. ये clear हुआ? शुभाकर, electrical, everyone? Because see, जैसे ये हो गया ना, suppose this is 4 ampere, and if I say these two circuits are identical, so from here we can say that both will supply 2 ampere of current, because these two are identical. है कि नहीं? Okay. Now, in the MMF, what we need to use? Let me add a page here. In the MMF, so MMF supplied from the primary side. So, MMF is what? Number of turns on the primary side. So, N11 into I1 plus N2 into I1. So, this is the MMF which is supplied from the primary. And what at the secondary side? What is the number of turns? N21 into I21. N21 into I21 plus N22 into I22. So, N11 is 4 into I1 is I think I1 we need to calculate plus 2 into I1, N21 is 1 into I21 is 2, N22 is 1 into I22 is 2. तो ये कितना हो रहा है? 6I1. This is equal to 4. Again, I1 is equal to 4 by 6 or 2 by 3 ampere. The same value we are getting. So, I think it is like it is easy to understand the method 1. But since we have discussed about the two method and both the method are having their different meaning, so those who are comfortable with the method 1, they can opt for they can go for method 1, and those who are comfortable with the method 2, they can easily use method 2, because this method 2 will help you a lot in the upcoming questions. Okay? All right. So, I hope this question is clear. Any doubt? Any doubt in this question? Let us move on to the next one. Sorry. And let me give you the let me give you the 2 minutes for this again. 2 minutes for this particular question. Is it clear, Subhakar? Electrical, any doubt? Okay. Do it fast. The equivalent circuit for a 200-400 volt single phase 50 Hz 4 kVA transformer is shown. For a current of 10 ampere at a 0.8 lagging power factor at high voltage side, estimate the low voltage input current and the efficiency. So what we need to calculate? We need to calculate the current at the low voltage side as well as the efficiency. Guys, please do share the session link with your friend. Again, I am seeing a very few students over here because only few of them are constantly replying the chat box. I don't know why others are sitting idle. So please do not do like that. Please, whatever answer you are getting, please share over the chat box so that I come to know that how many of you are getting the correct answer and how many of need to do the correction in the calculation part. Okay. Fifteen seconds remaining. Do it fast. Any answer? At least for the part A. Time's up. Okay. 20 ampere. Let me check. Yeah, you are near to the answer, but not exactly 20 ampere. It is 20.73 ampere. So excellent, excellent. Your answer is near to the correct answer. Okay. So excellent, Subhakar. Alright, please try for part B and let me start the solution from the scratch. Okay, so one thumb rule, whenever you are going to have the question from the transformer, always refer the secondary to the primary or reverse, primary to the secondary. It is always easy, or the question will become very easy if you refer the secondary to the primary side, because the primary side parameters are very like much higher than the secondary side parameter. So here we need to transfer only two parameters if I talk about the impedance, but if you transfer the primary to the secondary side, you are going to refer more than two, 1, 2, 3, 4 and so on and so forth. So it is always easy to refer the secondary to the primary, and it is thumb rule. Please remember this point. Okay. So what I will do, I will refer the secondary to the primary side. So let me write here, refer secondary to primary side. Okay. So let us see what we are having. This is 200 volt, I guess. Next we are having the shunt branch, na? This is resistance 600 ohm. This is magnetizing reactance, which is 300 ohm. Next 0.15 ohm, and this is J 0.15 ohm. Better to write here as well J value 300, because this is reactance. And next thing, since you are referring this particular impedance to the primary side. So as I told you in the first question, how we can refer? This will be a source, this will be a destination. So it will become 1 into 1 into. So this 200 and 400, this is what? This is the no load EMF. So the no load EMF are always depends on the number of turns. So here the ratio is also nothing but your turns ratio. So you can directly write here 200 volt and 400 volt. So turns ratio are also related to their induced EMF. So these are the induced EMF. Please do not think the source voltage. These two are different. These 200, 400 are the induced EMF. Okay, all right. So this is nothing but you can take this as a N2 and you can take this as N1. Means the ratio. So your ratio will be what? 400 divided by 200 ka square. Just a second, let me check. No, 200 by 400. 200 by 400 ka whole square. Similarly, J1 into 200 by 400 ka whole square. And you have a load as well. Like this, sorry. Okay, that's all. Now let me mark some notation over here. This is the actual load voltage V2, actual load current I2. This is I1 dash. Let me take here supply current I1, which we need to calculate I1, no load current I0. This is IC, core loss current, and this is magnetizing current. Now we are referring this all parameter to the primary side. So if you see carefully, it will become V2 dash and here current will become I2 dash. So the current here is I1 dash, which is this current, and this is supply current I1, which we need to calculate. This is I0, this is IC, and this is IM. That's all. That's all. Now here, what is I2? What is V2 dash? V2 dash is nothing but actual value into destination divided by source, which is equal to V2 by 2. Now in the question, if you see carefully, your current, which is 10 ampere, is at power factor 0.8 lagging. So the current I2 is lagging the voltage V2. So what it means, V2 is now going to be taken as a reference. So from this reference, this I2 is going to be lagging or leading. So first let us calculate the power factor angle. So I2, let me write here, I2 is 10 ampere and cos phi, which is equal to 0.8 lagging. So from here phi will be equal to what? Cos inverse 0.8 kitna hota hai? It will be 36.87 degree. So your I2, the phasor I2 will be equal to magnitude in polar form 10 at an angle of minus 36.87. Why minus? Because of the lagging. Done. Alright. And here V2 is at an angle 0 degree, because here the current is lagging with respect to the voltage. Yes, 36.86 or 87 if you round off this particular angle. Okay, done. Is it clear? So please do not get confused. This V2 is a polar form, this is magnitude of V2 and this is reference. Done, my friend. Okay, let us calculate the things over here. Now since you have taken the reference V2, then other cannot be taken as a 0 degree. Like see, here you cannot take 200 volt as a 0 degree, because already you have taken the reference. So what it means, this V1, let me take this as V1, just a second. Let me take this as a V1, this is in polar 200, which is a magnitude, and what about angle? angle should not be taken as 0 degree. It will be something as alpha. Let me take alpha because 0 degree you have already taken. Done. Okay. So my task is to calculate I1. So how I can calculate? Okay. I can also get this I2 dash value. How? Let me inbox this. Just a second. Let me inbox this. Okay. From MMF balancing. Primary side MMF, what is that? I1 dash current means the current entering into the winding, not the source one. What is current entering into the winding? I1 dash into N1. This is equal to current at the secondary side, which is I2 into N2. So I1 dash, this is 200, this is equal to I2 was 10 ampere at an angle minus 36.87 degree. Please do not take only magnitude, it is phasor. Okay, it is like this into N2, because ratios are nothing but the ratios, this turns ratios are the ratios of the induced EMF. Okay, so from here what we are getting? See, 20 at an angle, I1 dash is 20 at an angle minus 36.87 degree ampere. Done. So I have got this I1 dash value. So can I able to calculate? This I1, or else what we can do? I1 I can easily calculate. See how? Apply current division rule. Apply current division rule. I1 dash is equal to total current I1 into opposite by sum, means opposite impedance. I1 dash is here. What is opposite impedance? This one. Parallel combination 600 okay, 600 कहाँ गया? Yeah, 600 parallel J 300 divided by total sum of the impedance 600 parallel with J 300 plus 0.15 and this value will be what? ये value कितना आ रहा है? 1 by 2 means 1 by 4, it will become 1 by 4, 0.25. It is also 0.25. Okay, नहीं, यहाँ पे problem हो जाएगा because we don't know this V2 dash or load. We are not knowing this one. So yeah, it won't work. So we will have to look for the alternate. So what is alternative? What is alternative? Let us apply KVL in this loop. Let us apply KVL in this loop. In the dashed one. Okay, in the dashed one, let us apply. So minus 200 at an angle, apply KVL in dashed loop. So what we are going to get? Just a second, let me write. Minus 200 at an angle alpha plus क्या होगा? 0.15 0.25, what it will become? 0.4 I1 dash plus 0.15J plus 0.25J. So it will again become J 0.4 I1 dash plus V2 dash equal to 0. Done, my friend. Next. So 0.4 or 200 at an angle alpha, this is equal to 0.4 plus J 0.4 I1 dash. I1 dash क्या था? Somewhere we have calculated I1 dash is 20 at an angle this. So this is nothing but योर I1 डैश प्लस V2 डैश, वो क्या था V2 डैश, V2 by 2. So since this is a reference, so this is V2 by 2, V2 at an angle 0 degree divided by 2, like this na, we can write. Okay, so see, this is 200 at an angle alpha 0.4 plus j 0.4, this is 20. ये पता है आप लोगों को, R at an angle theta, this can be written as R cos theta plus j R sin theta. What is this? Or where you have seen this kind of terms in mathematics or in control system? In the root locus you have seen. R at an angle theta is nothing but a Euler form. This can be written as like this. So similarly, if you look at here, 20 cos minus 36.87, so it will be 0.8 minus j 0.6. Okay, so this value nothing but this one, R cos theta plus j R sin theta. Okay, next thing is plus V2 by 2 cos 0 plus j sin 0, so it will be V2 by 2. Chalo, so similarly this can be also written as 200 cos alpha plus j 200 sin alpha. So let us resolve this, and I have the value over here. Let me write it directly. So when you solve this part na, you will going to get 11.2 plus V2 by 2, which is a real part on the right hand side, plus j 1.6 plus j 1.6. Let me add a page. Okay, done. Okay, so these two things will be equal when the real part on both sides and the imaginary part on both sides are same. So from real part, 200 cos alpha, this is equal to 11.2 plus V2 by plus V2 by 2, and from imaginary part, which is 200 sin alpha, this is equal to 1.6. Okay, 1.6. Now from here, alpha value will be equal to, let me see, 0.46 degree. Please check it. Now substitute this alpha in this equation. What we are going to get? V2 value. So 200 cos 0.46 degree 11.2 plus V2 by 2. So this implies V2 value will be equal to 377.6 volt. Any doubt? Okay, I think we had calculated all the things, na? Done. Okay, all right. Now come to I1. What is I1? I1 is nothing but I0 plus I1 dash. I1 is nothing but I0 plus I1 dash, and I0 is IC plus IM plus I1 dash. I0 is this one. So what is IC? IC, if you see carefully, 200 at an angle alpha by 600. IM 200 at an angle alpha J 300. So ये जो हो जाएगा आपका 200 at an angle alpha is 0.46 degree divided by 600 plus 200 at an angle 0.46 divided by J 300, and I1 dash was 20 at an angle minus 36.87 degree. So when you solve this, you will going to get 20.73 at an angle minus 36.4756. 4756 degree. Any doubt, Subhakar? Everyone? So this is what your I1 value. Now let us calculate the efficiency. Let me change the color. Let us calculate the efficiency. So for the efficiency, we require the output and we require input. Done. So what is input Pi? Voltage here is, kahan gaya V1, 200 at an angle alpha. So 200 into I1, 20.73, V into Y into cos of angle between voltage and current into cos of, what is the angle difference between voltage and current? So here alpha 0.46 and here minus 36.47. So what is the difference? Take the subtraction, na? We will get 0.46 minus of 36.4756 degree. So from here we are getting the value of input power as 3313.945 watt. Done. Similarly, output power, this will be equal to V2 I2 cos of angle between V2 and I2. So V2 was, क्या था V2? 377.6. I2 was 10, not I2 dash, it is I2 into, दोनों के बीच में difference in angle cos of 36.87 degree. So this value is 3020.8 watt. Okay, let me add a page. So percentage efficiency is equal to output power 3020.8 whole divided by input power, which is 3313.945 into 100%. So this value will coming out to be as 91.154. Is it clear, everyone? So yes, Shubhanga has got the correct value of the angle, which was 36.86 degree. All right, excellent, excellent, everyone. So this is the correct answer for this particular efficiency. And what was the I1 value? This was the I1. So let us move on to the next problem. Any doubt in this question? Any doubt? Okay. Let us move on to the next one, and this question is very easy. This question is very easy. I want all the students to please attempt this question, and I will going to give you 1 minute, not more than that. I will going to give you 1 minute for this. Your time starts now. The percentage resistance and percentage leakage reactance of a 5 kVA, 220 volt, 440 volt, 50 or single phase transformer are respectively 3% and 4%. The voltage to be applied on to the HV side to carry out short circuit test at the rated current is. So basically this question belongs to the testing of a transformer, that is short circuit test. Do it fast. Any answer? Okay, so look at here. Under short circuit test, the applied voltage is very, very less than the rated voltage to circulate the rated current. I am repeating it once again. To supply the rated current in the transformer, the applied voltage is very, very less than the rated voltage. ठीक है, वो क्या होगा? VSC, that is the voltage applied under short circuit, is equal to percentage impedance into full load voltage. So what is full load voltage? We need to see the voltage on HV side. So see, high voltage, which is high voltage among this 220 and 440? 440 volt. So which is VFL. So percentage impedance, let me take equation 1. So percentage impedance Z is nothing but percentage resistance का square plus percentage reactance का square. This is very important formula from the transformer percentage impedance. Now we have all the values. Let me put a margin here. So we have all the values. Percentage Z, this is equal to root over, हाँ कितना है 3% whole square plus 4% whole square, so this will become 5%. So VSC is nothing but 5%, means from equation 1, 5% of 440. So this is equal to 22 volt, which is given in option C. So option C is the correct option for this question. So please remember this VSC formula under short circuit and this percentage impedance, and rest will be your calculation part. So let us move on to the next problem, which is this one. Okay, yeah, 100 kVA 2500 250 volt single phase transformer has the following result. Open circuit test 250 volt 0.8 ampere 80 watt. Short circuit test 60 volt 3 ampere 45 watt. Then the efficiency at half full load at 0.8 power factor lagging will be. So basically this question is related to the testing of the transformer. Now in the open circuit, basically we know that in the transformer we are having two types of losses. First one, constant loss or iron loss or core loss, which is given by the open circuit test, and the second loss is variable loss or copper loss, which is given by the short circuit test. So from here we come to know that open circuit test is giving us 50 watt is nothing but your iron loss, and this is short circuit test which is giving the loss as 45 watt, which is nothing but the copper loss. Now one catch is here. The short circuit test can be run at full load or it can be run less than the full load. What it means? It means that this value can be full load copper loss, or as well as it may be less than the full load copper loss. So how we will come to know that? By checking the full load current. By checking the full load current. Okay. So yeah, efficiency we need to calculate. So let me write first formula. Let me first write the formula. So percentage efficiency is equal to X into S into cos phi. This is output power into output power plus losses, cos phi plus iron loss plus X square times of full load copper loss into 100%. Now in the question we need to calculate half full load. So this X is what? Fraction of full load current. So this is nothing but your X value. So X is half, which is 0.5. Power factor is 0.8. Cos phi is 0.8. S is given in the question, that is rating of the transformer. S is 10 kVA. So 10 into 10 to the power 3 volt ampere. And what else? Iron loss. See, from the open circuit test, from OT, iron loss is given as 50 watt because it is independent of load. Independent of load. Done. Now my task is to calculate this PCU FL, because this is the unknown. If I have this value, I'll be having my percentage efficiency. Now how I will going to calculate PCU FL, means full load copper loss. This 45 watt, it can be full load or it may be less than the full load copper loss. So for that we need to check whether this particular test is run on full load value or not. How we can check? Open circuit test always perform on low voltage side. Short circuit test always perform on high voltage side. So what is high voltage? 2500. Now we know from the basics of the transformer, the kVA rating of the transformer are same on both sides, on the primary side and on the secondary side. So E1 I1 is equal to E2 I2. Let me write E1 I1 dash. Okay, not the I1. I1 was the supply current. I1 dash was the current which is entering into the winding. So this is nothing but the rated power of the transformer. Okay. So 25, I need to calculate the rated current on the high voltage side. So 2500 into, so 2500 is what on the edge, primary side. So let me take 2500 into I1, which is equal to 10 into 10 to the power 3. This is what given in the question, 10 kVA. So what is I1 value? So 100 by 25, so it will become 4 ampere. So yes, my dear friend, your test was not conducted at the full load. Therefore, this is not the full load copper loss. So how we can calculate? Okay. So remember, copper loss at X times of full load. Copper loss at X times of full load is equal to X square times of full load copper loss. This is one relation, and one more relation. Let me take this as first and second, means the first important formula, and the second one, copper loss is nothing but your current ka square into resistance. Current ka square into, or we can write that if resistance is constant, which is always true in the transformer, if resistance is constant, then your copper loss is a function of current ka square. Current ka square. Now in the question, it was given that for 3 square of current, I square, na? For 3 square of current, the copper loss was 45 watt. Then for full load, what is the copper loss? It will be 4 square by 3 square into 45, which is nothing but your 80 watt. 16 into 5, 80 watt. Done? Any doubt? Okay, so we have got the full load copper loss. This is nothing but your PCU FL. Now we have all the values substitute in this efficiency wala formula. So percentage efficiency is equal to X is 0.8 into S is 10 into 10 to the power 3, cos phi is 0.8. So 0.8 into 10 into 10 to the power 3 into 0.8, sorry, X was 0.5, na? Just a second. है ना? X was 0.5, okay, yeah. Plus iron loss was 50 plus X square PCU FL means 0.5 ka square into PCU FL is 80 into 100%. So when you solve this, you will going to get the numerical value as 98.28%. How was the question? It was difficult or easy? So this question you can expect in the GATE exam or in the upcoming GATE exam, because if you if you see at the beginning of the of this session, I told you one important topics. So in that, the efficiency was the topic. Okay. So if you have understood all the concept over here, now nobody in the world can able to stop you to get the full marks in the transformer. Okay. So let us move ahead with the next question, which is this one. A 100 kVA 11 kV 400 volt single phase transformer has its maximum possible efficiency of 98% when it delivers 80 kVA at unity power factor and rated voltage. The maximum possible voltage regulation of the transformer is 4%. The percentage efficiency of the transformer for rated kVA output at 0.8 lagging. Okay, so let me note down the data which are given here. S is 100 kVA, 11 kV divided by 400 volt. Next, maximum efficiency. This is 98% or 0.98 and when it delivers means S at maximum efficiency means the transformer is not loaded at full load, rather it is loaded at less than the full load to have the maximum efficiency, which is 80 kVA. Done. The maximum voltage regulation of the transformer is 4%. Okay. Find the percentage. Okay. So this is nothing but your percentage Z. Maximum voltage regulation is nothing but the percentage Z, which is redundant here. Okay. Now my task is to calculate the percentage efficiency when the transformer is loaded with a rated kVA. Means what is X value for the rated? It will be 1. So let me write here rated kVA, which is 100 into 10 to the power 3 into cos phi is 0.8 upon this is output power plus losses plus iron loss plus X square times of PCU FL. Since X is 1 for this, X is 1, so it will be PCU FL only. So what are the things which are unknown? Iron loss and full load copper loss. If I have these two value, I will be having my answer. Okay. So let us start with the solution part. Okay. So from the maximum efficiency, whenever you are going to see the maximum efficiency, one important point should strike to your mind. And what is that? Under maximum efficiency, your X square PCU FL is equal to iron loss, not ulta. Ulta will be wrong. Your X square PCU FL is always equal to iron loss. So under the maximum efficiency, these two losses are equal, where X is the fraction of load when the maximum efficiency was occurring. Now how to get this X value? Now if you see carefully, S at efficiency, this is nothing but X times of rated value. So X, what is rated? 100 kVA. And what is this? 80 kVA. So from here, X value I am getting as 0.8. Am I clear? Any doubt? So this is alternative. Basically, this is one more approach to get the X value. So let me down this formula. Write down this formula. Efficiency maximum divided by S rated. Okay, done. Okay, all right. So substitute in this formula maximum efficiency. So eta maximum will be equal to what? 98%, which is equal to X into S into what was the power factor? It was unity. So 1 whole divided by 0.8 into 100 into 10 to the power 3 into 1 plus, since both losses are same, so I can write here 2 times of iron loss into 100%. Only unknown is iron loss. So when you solve this, you will get iron loss as 816.3265 watt. 3265 watt. Now from here, can I able to get the full load copper loss? Can I able to get the full load copper loss? Yes, because at maximum efficiency, your x square times, which is 0.8 square PCUFL is equal to iron loss, which is 816.3265. So PCUFL is equal to, so this is equal to 1275.51 watt. Done. So we have all the values. Substitute in this formula. So this so from here, percentage efficiency will be equal to, क्या था value? 100 into 10 to the power 3, 100 into 10 to the power 3 into 0.8 upon 100 into 10 to the power 3 into 0.8 plus iron loss, which is 816.3265 plus full load copper loss, which is 1275.51 into 100%. So on solving this, we are going to get the efficiency as 94.452%. Okay, what is the learning here? The learning is maximum efficiency can be occur at full load or it can be occur at less than full load. It is not always true that the maximum efficiency occur at full load. Got the point? And what are the other learning? At maximum efficiency, your copper loss at any load, X is basically a fraction of full load. So your copper loss at any load is equal to iron loss. So these two important formula you need to be remember from the maximum efficiency. So the correct answer is 94.45, which is given in option D. Done? Any doubt? Let us move on to the next question, which is here. Two single phase transformer operate in parallel to supply a load of 44 plus J 18.6 ohm. The transformer A has a secondary EMF of 600 volt on open circuit with internal impedance of 1.8 plus J 5.6. It has to be J 5.6 ohm referred to the secondary, whereas transformer B has 610 volt plus 1.8 plus J 7.4 ohm. Calculate the terminal voltage, current and the power factor of each transformer. So this question is basically related to the topic parallel operation of transformer. Okay? So let me make the diagram for this. So let us take this as transformer A, which is having the impedance A and EMF as EA. Similarly, we are again having the one more transformer, which is B, transformer B or second transformer you can say, which is having the open circuit voltage as EB. And this is your load. ZL. So let us have the current from the transformer A as IA, from transformer B as IB, and the load current as IL. Just a second. And this voltage, load voltage, which is nothing but the terminal voltage as V, terminal voltage as V, and this is your ground. So what we need to calculate? Terminal voltage V, current of each transformer which is IA and IB, and power factor of each transformer. Now apply KCL at this node. Okay, so let me write KCL at node X. What we are going to get? See, what is the voltage at X node? The voltage is V, which is nothing but the load voltage. So V minus EA whole divided by ZA plus V minus EB divided by ZB plus V by ZL. Okay, what is EA? EA is 600. What is ZA? Is this value. What is EB? 610. What is ZB? This value. And what is ZL? This value. Substitute all the values which is given over here in this expression. We will get V value as. So let me write the value directly so that we can save some time for the other question as well. So substitute all the values here. We'll get V value as 578.286 at an angle minus 2.983 degree volt. So this value of voltage we are supposed to get, which is nothing but the terminal voltage. So we have got one value. Now individual transformer current. So IA is what? EA. See, what is the direction of the current? From the source to the node X. So EA minus V, this voltage V whole divided by ZA. So from here substitute all the values of EA. So what is the reference? Is 0 degree. Here the reference is 0 degree. So 600, see, 600 at an angle 0 degree minus this value divided by ZA. ZA is this one. So we will going to get the IA as 6.388 at an angle minus 18.94 degree ampere. Similarly, IB, it will be EB minus V divided by ZB, and this value is coming out to be as 5.815 at an angle minus 33.53 degree ampere. So we have got the two values. Now other is to calculate the individual power factor of the transformer. So power factor of transformer A, cos of angle difference between the current IA and the voltage which is appearing over here. So कितना होगा यार? See, it is minus 2.983 minus of minus 18.94 degree. So this is the phase difference between the voltage and the current for the transformer A. So on solving this, we will going to get the answer as 0.961 lag. Similarly, for power factor of transformer B, it will be cos of minus 2.983 degree minus current angle is minus 33.53 degree, and this is coming out to be as 0.861 lag. Why lag? Because current are more lagging in nature than the voltage. So I hope you have got the concepts of these questions are not frequent if you see the last 5 to 10 year of question, but you never know, if our luck is bad, we may going to get such kind of problem. But we are sure that since we had studied this particular question here, we can attempt any question in the upcoming GATE exam from this particular topic. Okay. So let us move on to the next one. So we have completed all the topics which are important with respect to the GATE exam for the transformer. Now let us come to the induction machine. Again, it is common for both EE and IN. And what are the weightage? Weightage is written over here, 2 to 4 marks for EE, and for IN it will be 1 to 2 marks. And what are the important topics in the induction machine? It is slip and rotor frequency, equivalent circuit of induction machine, power flow diagram, starting of induction motor, and speed control of induction motor. Okay? So let us start with the first question under this. A 3-phase 4-pole slip ring induction motor is connected to 3-phase 50 Hz supply from the rotor side through slip rings. The stator terminals are shorted and machine is found to be running at 1440 RPM. Determine these following points. This is not the options, these are the questions that we need to be find out. Okay. So let me note down the data given. It is a 3-phase slip ring induction motor. The rotor can be made in 2 types. One is squirrel cage and the another one is slip ring or wound rotor. In the wound rotor we have a facility or in the slip ring we have a facility that we can externally connect the resistance in series with the rotor, so that the power factor or the torque can be enhanced. Okay, this can only be feasible in slip ring induction motor. It is not applicable for the squirrel cage. All right. And what else? Rotor speed NR, this is 1440 RPM. Done. All right. So let us first calculate the synchronous speed NS, which is nothing but 4 pole is given, which is nothing but 120 F by P. So 120 frequency is 50 Hz, which is given here. 50 Hz divided by number of poles, which is 4. So this is coming out to be as 1500 RPM. Now part A, stator and rotor current frequency. So stator current frequency is nothing but your supply frequency. Remember, stator current frequency is nothing but the supply frequency, which is nothing but 50 Hz. This is stator current frequency. Next, rotor frequency, which is F2, is S into F1, where S is the slip and it is having the formula as Ns minus Nr by Ns. So this is slip formula into F1. Okay, तो ये क्या कितना है? Ns is 1500, Nr is 1440 divided by 1500 into frequency is 50 Hz. So this is coming out to be as, let me see, this is coming out to be as 2 Hz. Please check everyone. So part A is completed. What about part B? Speed of rotor magnetic field with respect to rotor. So rotor magnetic field with respect to rotor means rotor speed. So rotor rotating magnetic field or rotor magnetic field is always rotate with the synchronous speed. So Ns minus Nr. This is 60 RPM. Because for the machine is going to be work if the proper torque is developed in the machine, and for the proper torque production, the relative speed between the two rotating magnetic field. One is from stator side and the another one is from the rotor. Rotor side. I am talking about the magnetic field, not the speed of the rotor. Okay. So whenever the rotating speed of the magnetic field of the stator and rotor, or you can say the relative speed between the rotor rotating magnetic field and stator rotating magnetic field are zero, then the torque is going to be produced. ठीक है, समझ में आ गया? And what is the speed of the rotor rotating magnetic field or rotor magnetic field? It is always synchronous speed. Next, C part, speed of the stator magnetic field with respect to rotor. Stator magnetic field with respect to rotor. As I told you, this both speeds are same, which is always synchronous speed. So again it will be 60 rpm. And the last one is D part, speed of stator magnetic field with respect to rotor magnetic field. Since both speed are synchronous speed, therefore it will be 0 rpm. Am I clear? So please note this point in your note copy. This is very important. This may going to help you out in the GATE problem. Okay. So let us move on to the next question. A star connected 440 volt 50 hertz 4 pole induction motor has the following constant in ohm per phase to the stator side. R1 equal to 0.294 ohm, X1 equal to 0.503 ohm, R2 dash equal to 0.144 ohm, X2 dash 0.203 ohm and XM 50 ohm. Stator core are negligible, very important line. Friction and other losses are 1400 watt. Find the efficiency, output power in kilowatt and torque in Newton meter if motor is being operated under rated voltage and frequency at 2% slip. So let me give you 2-minute time for this, and after that I will start the solution. Do it fast. Any answer? Any answer, my dear friend? Your time's up. Okay, so look at here. To solve this kind of question, we first have a clear idea regarding the power flow in the induction motor. So this is your power flow diagram of the induction motor. Since this is a motor, so input will be electrical and output will be mechanical. So input is connected at the stator side and output, since it is a mechanical, so output will be at the rotor side. Now input is electrical, which is the stator input, and after that after you deduct the losses at the stator side, which is nothing but the stator copper loss or the stator core loss or iron loss, you will come to the air gap. So the power which is transferring from the stator to rotor via air gap is known as air gap power, or stator output power, or rotor input power, because after the stator rotor will come. So therefore output of the stator is equal to input of the rotor. Therefore rotor input power, and once you deduct the rotor losses, you will going to get the gross mechanical developed power, which is PGMT. Now when you again deduct the friction and windage loss from the gross mechanical developed power, you will going to get the output power, or you can say rotor output is not exactly correct. Let me write here shaft power. It is shaft power. Shaft power or output power, or output power, or it is also known as net power. Okay, PSH. I hope this is clear to you. Done. So this is nothing but the power flow diagram of the induction motor. Now we will going to take the help of this, and after that we will going to draw one equivalent circuit, so that we are going to have the equivalent values in terms of electrical parameter to have the numerical values, so that we can going to have our efficiency and the remaining quantities, isn't it? So let us make the equivalent circuit of the induction motor, assuming that your core loss is negligible, and we know that the equivalent circuit of transformer and induction motor both are same. Okay, so let me draw it directly here. This is R1, this is X1, this is stator. Here we are going to have the stator voltage, which is V1. Next, magnetizing reactance. Here Muhammad Nafiz Alam, yes sir, okay. So here you are going to have what? Core of the stator. Since core loss is what? Neglected, so I am not connecting the RC in parallel. Otherwise, if in the question the core loss has to be taken na, then in parallel you will have to connect the RC, which is core loss of the stator. But since we need to neglect, I am not drawing that particular element. Okay, so this is JXM, or let me write simply XM. And after that you will be having X2 rotor resistance, and this is R2 X2 dash, this is R2 dash, and this is R2 dash 1 by S minus 1. All right. So this is the equivalent circuit of your three-phase induction motor. Okay, so look at here. Let me divide this particular induction motor into some segment, so that we can easily understand the power flow. Okay. So yeah, see, this is your stator side. Okay. something we have missed. Yeah, we have missed the current. Which color we should take? We take white color. Okay. So this is stator current I1, no load current I0, which is nothing but Im, because IC is neglected over here. This is I1 dash, and since you have referred the rotor to the stator side, so your I2 will become I2 dash. Done. So all those dash, what it implies? It implies the referred parameters. So done. So look at here. First, stator input will be given. Then this is your stator copper loss and core loss. Since core loss is neglected, so you are left with the copper loss. After that, where it went? Yeah. This is your rotor copper loss, or it can simply be written as PCU. Both are same. In some book we write PCU for the rotor copper loss, and this is what? This is PGMD, gross mechanical developed power. So after this you will going to subtract with the friction and windage loss to get the shaft power or output power. Now in terms of their parameters, what is this? Let me use a different color. In terms of parameters, how we can write? This is per phase electrical circuit, but since induction motor is what? 3 phase, na? So let me write in 3 phase manner. So your input PSI is nothing but root 3 times of, where should I write? Yeah, let me write here, root 3 times of, or 3 times, so let me write 3 times of V1. V1 is what? Per phase supply voltage into I1 cos phi 1, where phi 1 is the angle between V1 and I1. PCU, so this will be the stator copper loss, 3 times of I1 square into R1. Next, rotor copper loss, 3 times of I2 dash square into R2. And what is gross mechanical developed power? See, this parameter is the parameter for the gross mechanical developed power, this resistance basically. So this is equal to 3 times of I2 dash ka square R2 1 by S minus 1. Done. This much concept is required to solve this particular question. So, sorry. So what are the data which are given in the question? Let me write it. 0.294, 0.503, 0.294, 0.503. Then R2 dash 0.144. This is 0.144. X2 dash 0.203 means J 0.203. JXM, which is J50, and this R2 dash is 0.144. 1 by S. S is a slip. What is the slip value, my friend, here? Somewhere it is written 2%, means 0.02. So 1 upon 0.02 minus 1. Done. So my task is to calculate this PGMD. So how I can calculate? Supply voltage is given in the question. Yeah, 440, and it is star connection. So what is the per phase voltage? Per phase voltage, let me use different color, the red one. Let me use the red one. So V1 value, let me write here, V1 value is 440 at an angle 0 divided by root 3. This is per phase value. And what else? Friction and windage loss. This is given in the question as 1400 watt. Just a second, let me check. Friction and windage loss is given, na? Yeah, friction and windage loss. Basically, other loss means it is a windage. Na? This is given. Okay, let us calculate then. Okay. I1. I1, this will be equal to what? This supply current, it will be equal to supply voltage V1 per phase voltage means whole divided by, see, R1 plus JX1, R1 plus JX1 plus parallel combination of this and this. क्या होगा? JXM parallel with R2 dash by S. See, this R2 dash and this R2 dash will going to be cancelled out. Na? So, you, in this particular thing, the resistance value will be R2 dash by S. So, R2 dash by S plus JX2 dash. So, this is the parallel combination. Substitute all the values, substitute V1 is this value, supply voltage per phase. Substitute all the values, will get the answer for I1 as 30.835 at an angle minus 13.19 degree ampere. So, this I1 value or supply current we are going to get. Next, I need to have this PGMD. For that I require I2 dash, which is nothing but I1 dash. So, what is I2 dash? Apply voltage, apply current division rule. We will get I2 dash as total supply current I1 into opposite, which is JXM, divided by sum, which is JXM plus R2 dash by S plus JX2 dash. So, on solving this, we have all the values, na? On solving this, we are going to get the answer as 30.4 at an angle minus 5.03 degree. I am not substituting all the values because we have, like, we are here to learn the concept, not to calculate the numerical values. Okay. So, once you substitute all the values in your calculator, you will have this I2 dash value. Now, from here, what is PGMD? PGMD will be 3 times of I2 dash ka square into R2 dash 1 by S minus 1. So, here I2 dash is magnitude, which is 30.4 ka square, 3 into 30.4 ka square, R2 dash 0.144 into 1 upon 0.02, which is slip, minus 1. So, from here we are going to get the value as 19.563 kilowatt. So, this is not your output power, this is the gross mechanical developed power. So, after this we need to subtract the friction and windage loss to get the output power. So, P shaft or output power, this is equal to PGMD minus friction and windage loss, which is 1.4 kilowatt. So, this becomes 18.163 kilowatt. Done. Let me add a page. Done. Now, what is shaft power? Sorry, what is shaft torque? What is shaft torque? Torque is what? Power divided by speed, rotational speed, which is nothing but shaft power divided by rotor ka speed. So, PSH divided by omega R is written as omega S 1 minus S. Omega S is 2 pi NS. NS is 120 F by P. So, from here, what is T shaft? T shaft is 18.163 into kilowatt whole divided by omega s 2 pi ns by 60. ns is 120, f is 50 hertz. Number of poles क्या था? What is the number of poles? 4 into 1 minus s. कहाँ गया? Yeah, 1 minus s, which is this thing, 1 minus s. So 1 minus 0.02. So shaft torque is 115.375 Newton meter. Done. So I think we are left with one more thing. Output power we have calculated, which is shaft power. Efficiency we need to calculate, and torque we had already calculated. So for efficiency, what we require? For efficiency we require shaft power, which is output power, divided by input power into 100%. Okay, so what is input power? It is 3 times of V1 I1 cos of angle between V1 and I1. So V1 is what? Reference. So its angle is 0 degree. So from here 3 into V1 is 440 divided by root 3 into I1 क्या था? 30.835. 30.835 into cos of angle between those two, 0 minus 0 is for voltage angle. I1 का angle क्या था? I1 angle was minus 13.19. Okay, so this value is coming out to be 20.8 kilowatt. 20.8 kilowatt. Okay, so from the formula of percentage efficiency, what we have? P shaft, which is 18.163 whole divided by input power, which is 20.8, this value, into 100%. So which is coming out to be as 87.32. Please check it, 87.32%. Okay, so what is the learning? The learning is we should be knowing the power flow of the induction motor. We should be knowing what parameter signifies which power. ठीक है? Here. Okay, so I hope you have understood this particular question very clearly, so that you are not having any doubts and you can attempt any question related to the power flow diagram. Come to the next one. A 400 volt 50 hertz 4 pole star connected induction motor has the following data: R2 dash 3 ohm, X1 plus X2 dash equal to 7 ohm. Full load torque normally occurs at a sleep of 0.03. For a constant load torque, to get full load torque at a sleep of 0.2, additional resistance to be connected in series with each rotor per phase in ohm is. So basically this question is what? Speed control of induction motor. By inserting the external resistance, we can change the slip, therefore we can change the speed of the induction motor. Okay, so what value we should be added as a resistor to have this particular slip for the same kind of load? बताओ क्या होगा? Okay, now see here, those who are knowing the formula, like those who are already knowing the formula, they can easily solve this question within a 15 second. Like see, 0.2, 0.03, here it is 3, it will get 20, 20 minus 3, 17. 17 is the correct answer for this question. Done? If you know the formula. But what if we are not knowing the formula? Then one person can save us, And who is that? Shaktiman? No, it's electromagnetic torque formula. Sorry for the PJ. So electromagnetic torque formula TE, which is equal to 3 by omega S into V1 square divided by R2 dash by S whole square plus X2 dash square into R2 dash by S. So this is the electromagnetic torque formula which is developing in the machine. Now in the question it has said that the slip was 0.03. So induction machine or the induction motor is operating at low slip region, and in low slip region, at low slip region, this parameter R2 dash by S is much higher than your X2 dash. It means we can approximate this electromagnetic torque equation. So TE is approximately equal to 3 by omega S into, see this is neglected, R2 dash by S ka whole square. So we are left with S times of V1 square by R2 dash. Now here can I say electromagnetic torque is proportional to 3 omega S V1 square is constant because we are not changing this parameter. So it is proportional to S by R2 dash. S by R2 dash. Next, machine will work under steady state. So under steady state, your electromagnetic torque must be equal to your load torque. Now since load torque is constant, therefore electromagnetic torque is also constant. है कि नहीं? What it means? It means that S by R2 dash is constant. Therefore, when the external resistance was not added, let us take the slip as S1, and when the external resistance is added, the slip S2. समझ में आ गया? So when it was not added, what was the slip? 0.03, and when it is added, the slip become 0.2. So 0.03 resistance, rotor resistance was 3. This is equal to 0.2 whole divided by, just a second, 0.2 whole divided by 3 plus R2 dash external. Okay, so on solving this, we are going to get 3 plus R2 dash, R2E dash is equal to 0.2 into 3 divided by 0.03, which is nothing but 20. So from here R2E dash is equal to 20 minus 3, which is equal to 17. So I directly knowing this formula, I already knowing this formula. So those who are not able to remember the formula, they can directly approach the solution in this manner to arrive these particular steps. And those who are already knowing the formula, they can start the solution from here itself. So I have calculated all this thing in my mind. ठीक है? चलो. So I hope you have got the solution for this. The correct option is option B. Okay, here comes the next question. The speed of a three-phase induction motor is being controlled by varying the supply frequency. The frequency and the applied voltage are reduced to half and 3/4 of their original values respectively. The new maximum torque and the slip for the maximum torque are dash times their original values respectively. So we need to find the maximum torque and the slip for the new voltage and frequency. Okay, we'll see here. Initially, let the frequency F1 be F and the supply voltage V1 be V. Now since your supply frequency, let me take F1 dash, is reduced to half, it means that it will be F by 2. And your supply voltage V1 dash is now become 3/4 of the original or of the initial. Done. Alright. Now maximum torque or slip, let me write the slip formula first. Slip formula, what is this? Rotor resistance R2 dash divided by rotor leakage reactance. Now here you are having the frequency term in the reactance. So can I say your maximum slip is inversely proportional to the frequency? Are हाँ कि ना? Therefore Sm dash divided by Sm means Sm dash is now value, Sm is was the initial value, which is equal to F divided by F dash. F divided by F dash. So from here F upon, what is F dash value? This is F dash value, which is F by 2. Okay, this is F value, sorry, this is F dash value, which is equal to 2. Any doubt? Now come to the maximum torque, sorry. Now come to the maximum torque. Maximum torque formula Tm, let me use different color, Tm is equal to 3 by omega s into V1 square divided by 2x2 dash. Now again in this, omega s is what? 2 pi ns by 60 and ns is 120 f by p. It means that in omega s we are having one frequency term and here we are having one more frequency term. So can I say your maximum torque is proportional to V1 by f ka whole square. V1 by f ka whole square. So Tm dash divided by Tm, this is equal to V1 dash by f dash का होल स्क्वायर इंटू V1 by f का होल स्क्वायर. समझ में आया? And f is what? F1 and F1 dash. Okay, so this is f dash. This I have taken as f dash. Okay, substitute the values here. This value, this is 3 by 4 of V. And this is f by 2 का whole square into f by v. So on solving this, we are going to get 9 by 16 into 4. 9 by 16 into 4. So v square by f square will be cancelled out. So it is 9 by 16 into 4, which is nothing but 2.25. So in which option it is given? See, first maximum torque. So please do not take this option, it will be wrong, because first we need to answer for the maximum torque. So the first value is given for the maximum torque. So 2.25 and 2. So option C is the correct option. So intentionally I have given such kind of option because in the GATE exam you would be in such a rush that you may miss this particular statement, and by looking into the option A, that you have got 2 and 2.5, you will tick this and you will be thinking that yeah, we are going to get the full marks in this question, but my dear friend, it is not the correct one. You will going to have the negative mark or 0 mark, because first we need to give the answer for the maximum torque. ठीक है? Or okay. So please be careful. Always be alert while reading the question. Let us move on to the next thing. This is MSQ, multiple select question, means more than one option can be correct. The electromagnetic torque TE of a drive and its connected load TL are as shown below. Out of the operating points 1, 2, 3 and 4, the unstable ones are. So this question is basically related to the stability of the induction motor. Okay, so we need this load, what to say, the torque speed curve is given to us of a particular motor and the load, and we need to identify which curve is stable, sorry, which curve is unstable. Okay, any answer? MSQ question, this is MSQ question. Look at over there, MSQ question. Okay, so let me give you a hint, dynamic equation of the machine. So let us check the curve one by one. What we need to do, let me add a page first. What we need to do, see, let me take one example for you. Like how we can say that a particular thing is stable or particular thing is unstable. Since you had already studied in the control system, in the signal system as well, the definition of the stability, but how we can utilize those definition in our machine. See, a machine is meant to run a particular load, means it is running under the steady state, and when the machine is running under the steady state, it means it is rotating at a constant speed or at a fixed speed. Done. Now if a disturbance is happen, if the disturbance is happen, then there are chances that the rotor speed can be increased or it may be decreased. But ideally machine has to run at the same speed or the fixed speed. Now if the disturbance is given, or if the disturbance is occur in the machine, and suppose if the machine speed is increasing further, and it is never returning to its original speed, can we say that the system is stable? No. If the machine is not regaining its original speed, then it is said to be its unstable machine or unstable state. Similarly, if the machine speed is reducing further and further from the initial speed or from the original speed, and it is not returning to the original speed, then the machine is said to be unstable. Another way of saying the stability is what? If the disturbance is given and machine is returning to its original speed, then such machine is said to be stable machine. Now how we can use this particular thing in our problem? See, from the dynamic equation of a machine, we know that J d omega by dt, omega is the speed of the rotor, is equal to electromagnetic torque minus load torque. So this is the dynamic equation of the induction motor, or you can say any motor. This is valid for synchronous machine as well. Now what I will going to do, I will going to give the disturbance to the motor such that the speed is going to be disturbance. I am giving the disturbance to the motor such that the speed is increasing. Now if the machine itself going to increase the speed further, then the machine is said to be unstable, or else if the machine is reducing the increased speed, then the machine is said to be stable machine. So if a disturbance is given such that speed increases, then not if, suppose a disturbance is given such that speed increases, then there are two cases. First, if TE minus TL is greater than 0, this implies TE is greater than TL. So from here what we can say, d omega by dt is also greater than 0. So it implies speed is increasing further. Means you have given the disturbance such that speed is increased, and machine itself, because of this torque, increasing the speed further and further. Therefore, such kind of case is said to be unstable. Got the point? Next one. If TE minus TL is less than 0, this implies TE is less than TL. From here, d omega by dt is less than 0. It means that the speed is decreasing. Since you have given the disturbance such that the speed is slightly increased, but the machine is compensating those increased speed by reducing the speed. Means machine tries to regain its original speed. Here it is not getting the original speed. Therefore, the second case is said to be stable. If you have understood this particular concept, then you can easily able to answer this particular question. Now, let me show you how you can apply. See, I need to check whether this point 1 is stable or not. So, what I will do, I will increase or I will give the disturbance to the machine. I will give the disturbance to the machine. Okay. So, just a second. This was the original speed at which the rotor was rotating. Let me take N1. This color is visible. N1. Now, the new one was N1 dash. So, earlier the machine was rotating at this speed, N1 dash. Now, I want to check whether this point is stable or not. So, I have given the disturbance such that my speed is increased. Now, for new increased speed, look at here N1 dash, which is greater. See, this is the curve for TE, this is the curve for TL. So, for N1 dash, for the increased speed or for the disturbance which is greater, TE is greater than TL at new increased speed. So, what it implies? It implies that d omega by dt is greater than 0. यही लिखा था ना? Therefore, you have given the disturbance such that the speed is increased, and because of the machine which is not stable, the speed is increasing further and further and further. Therefore, speed increases and point 1 is not stable. Done? Come to the next one. Here it is running at a point 2. Let us increase the speed. See, this is the axis of the speed, na? So, here the speed is increasing in this direction. So, this is your N1, let me take N, this is the new speed N dash. This is the curve for TL, this is the curve for TE. Now, which is greater for the new speed? Which is greater for the new speed? Or what is the relation between TL and TE? So, for N dash, see, TL is greater than TE. Therefore, d omega from the dynamic equation, d omega by dt is less than 0. This implies speed decreases. Means you have given the disturbance, and since the machine is stable, therefore, it tries to get back to its original speed. Therefore, hence point 2 is stable. In the same manner, if you check for point 3, okay, so this is N, This point is N dash. This color is visible, na? N dash. So for N dash, which is greater? This is TE, this is TL. So for N dash, TE is greater than TL. Therefore, speed increases further, so it is unstable. Got the point? Any doubt in this? Similarly, for the fourth point, this was the steady state point. Let us increase the speed further. This is N, this was the new speed, N dash. So which is greater, my dear friend, here? Where is load torque? Yeah, this is load torque, the straight line, and this curve is TE. So see, TE is greater than TL. इसकी बात कर रहा हूँ, N dash की. At N dash point, see the torque value. TE is greater than TL at N dash. TE is greater than TL. This implies d omega by dt is greater than 0. This implies speed increases further. Therefore, point 4 is unstable. So point 1 except point 2, point 1, point 3 and point 4 are unstable. So our correct option is A, C and D. A, C and D. Any doubt? Any doubt, guys? Please do share the session link. I know you are enjoying the session, so please do me a favor. Not let play holy. Do me a favor, just share the link with a friend so that they can also get benefited by this session. Okay, at least this kind of thing you can do for me. Alright, so let us move ahead with the next question. And what we have? A three-phase star connected 50 Hz 12 pole 100 kilowatt slip ring induction motor drives a fan whose torque is proportional to the square of the speed. Very important line. At full load, the slip is 0.05. The rotor resistance measured between any two slips ring is 50 milliohm. What resistance in milliohm should be added in the rotor circuit to reduce the fan speed to 400 rpm? Okay. Let me give you 3 minutes for this, not more than that. Just a second, let me see. If you want more time, please do let me know. I will give you the more time. I will give you more time. Please do let me know. But at least try this question, because suppose if you would be getting the correct answer, then your confidence is going to be boosted up from this particular question or from the gate booster. ठीक है? Do it fast. Time's up. Time's up. Any answer? The correct answer is 116 milliohm. 116 milliohm. How many of you have got? How many of you have got 116 milliohm? Okay, so look at the board. This kind of problem or the concept related to this particular question we had already discussed. I think in the first or the second question. If you have gone through those particular question very carefully, you could be able to answer this question correctly. But no issue, I am here to help you out. So here we need to calculate the resistance that we need to add in series with the rotor, such that my speed decreases to 400 RPM. Okay, decreases to 400 RPM. Okay, so let me note down the data here. Given 3-phase star connection, 50 hertz, 12 pole, 100 kilowatt slip ring induction motor which drives a fan whose torque is proportional to the square of the speed. Means your load torque is proportional to the rotor speed. At full load, the motor slip is SFL. This is equal to 0.05. Let me take this as S1. Okay, 1 is for case 1. Na? Please do not think that the rotor, the stator slip. It is the slip for the case 1. The rotor resistance measured between any two slip ring is 50 milliohm. Okay, so let us keep this aside as of now, this data. What rotor resistance or what resistance in milliohm should be added? So let me take those resistances R external dash that we need to be find out, such that my speed N2 is become 400 RPM. 400 RPM. Any answer? Any answer? No. So always remember, whenever you are having the question for the speed control of induction motor, we always require the electromagnetic torque equation. Electromagnetic torque equation. And what was that? 3 by omega s into V1 square divided by R2 dash by S whole square plus X2 dash whole square into R2 dash by S. This was the approximate equation of the electromagnetic torque when the stator impedance is neglected. Okay? And this is true for most of the cases. Done. Okay. Now, at low slip region, what do you mean by low slip region? Whenever the motor is running, whenever the motor is running under steady state, then it is always at low slip region. Means the slip between the 0 to maximum slip. I hope you were knowing this kind of curve for the induction motor. है कि नहीं? So this is the peak of the electromagnetic torque curve. So therefore the slip corresponds here is Sm, and here the speed becomes synchronous speed such that the torque becomes 0. So this slip will be 0. Whenever the rotor speed becomes synchronous speed, the slip becomes 0, and therefore this point is what? 1, because this is starting of the induction motor, and this particular point is starting torque, and this particular point is maximum torque. This is torque slip curve. This is torque slip curve. Now see, Slip 1 to SM, this is known to be high slip region. High slip region, whereas SM to 0, this is known as low slip region. See the slip value, na? You will come to know. See the slip value. In the high slip region, x2 dash is much higher than your r2 dash by s, whereas in the low slip region, r2 dash by s is much higher than your x2 dash. This is said to be unstable region or hyperbolic region, and low slip region is known to be stable region or linear region because here the torque is proportional to your speed in the low slip region, whereas in the high slip region your torque is inversely proportional to the slip. If you are knowing this particular curve, na, you can solve any question of the induction machine. Okay. Now, at low slip region, as we had discussed, that R2 dash by S is much greater than your X2 dash. If you see in the question, what is slip? 0.05, and 0.05 is somewhere here. Therefore, your electromagnetic torque is approximated to 3 by omega s into V1 square divided by R2 dash by S. है कि नहीं? Because this is negligible. Take this to numerator. It will become 3 omega s into S V1 square divided by R2 dash. So if you see carefully, your electromagnetic torque is proportional to the slip. है कि नहीं? If all other parameters are constant, your electromagnetic torque is proportional to the slip. Therefore, torque is proportional to S. That is why it is said to be stable region or the linear region. Okay. So since the rotor resistance is not constant here, because you are inserting the external resistance at the rotor side such that the speed is going to be changed. Therefore, from here electromagnetic torque is proportional to S by R2 dash. Whereas the other parameters are constant for this question only. Now, under steady state, electromagnetic torque is always equal to load torque. So we have got S by R2 dash. This has to be equal to, load torque is proportional to speed ka square, na? So this is equal to rotor speed. This N is rotor speed. Done. Now for the case 1 and case 2, if you take case 1 and case 2 and divide both the cases, what we are going to get? S1 upon R2 dash whole divided by S2 upon R2 dash plus R external dash. Let me check R external, we had written, na? Okay. This will be equal to old speed N1 square divided by new speed. ये clear है? Is this particular equation is clear? This particular equation is for the initial case, and this particular equation is when the rotor is resistance externally added, external resistance you can say, such that the speed becomes 400. Okay, so what are unknown? RE dash we need to calculate. S1 is given in the question, S2 is not given, N1 is not given, but N2 is given. So let us calculate S2 and N1. First let me inbox this. and let me mark this as equation 1. Okay, so slip 1 is already given in the question, and we had already written as 0.05. Now let us calculate N1. Rotor speed N1 is equal to synchronous speed Ns1 minus slip, so S1. So synchronous speed is 120 F by P, 1 minus S1. So 120, frequency is 50 Hertz divided by number of pole is 12 na, let me check. ठीक है. So this will become 1 minus slip was 0.02. Let me check the data. Sorry, 0.05 na, sorry, 0.05. This 0.05. Okay, so this will become 475 RPM. We have got N1. Now what is unknown? S2. So S2 is synchronous speed minus new speed of the rotor divided by synchronous speed. So 1500, not 1500. Ns is 120 into 50 divided by 12, so it is 500. N2 was 400 divided by 500. So 100 by 500, it is 1 by 5.2 आ रहा है ना. It is 0.2. So therefore, slip increases, speed decreases. Now one more unknown is here, which is R2 dash. We have got all the values except R2 dash. Now indirectly it is given in the question. The rotor resistance measured between slip ring is 50 ohm. So since it is star connection na, so see here, this is your star connection. This is rotor resistance referred to the stator side. So it is R2 dash, and it is R2 dash. Now since this rotor resistance is measured by using voltmeter ammeter method, so connect the voltmeter here and connect the ammeter here, such that the ratio of voltmeter divided by ammeter will give you the measured resistance, so which is Rm. And what is this value? Rm is given as 50 milliohm. It is 50 milliohm. But we don't require Rm, we require rotor resistance value R2 dash. तो कैसे होगा? Since you have a 3 supply line na, disconnect one supply line, means no current will flow here. So current will only flow in this 2 line. Okay, in this 2 line. Current will flow in this 2 line. So apply KVL in this loop. क्या मिलेगा? Apply KVL in this two loop. V equal to current into 2 resistance will come na, so 2R2. समझ में आ गया? Apply KVL in this loop. Voltage equal to current into this 2 resistance. So this Rm is nothing but 2 times of R2 dash, which is 50 milliohm. So R2 dash is equal to 25 milliohm. We have got the rotor resistance as 25 milliohm. As I told you, it is indirectly given in the question. अगर वो क्वेश्चन में ही बता दे R2 dash, तो रहेगा क्या फिर हमारे पास फाइंड करने को? ठीक है, चलो. So we have all the values, substitute all the values in the equation 1. So from equation 1, what we are going to get? S1 is 0.05, R2 dash we have got as 25 milliohm divided by S2 dash is 0.2 whole divided by 25 milliohm plus R2 dash, sorry, R external na, R external dash, this is equal to N1. N1 was 475, no? Yeah, 475 divided by N2, 400 whole square. I substituted all the values in this equation. Let me check once again. Okay, correct. Now, when you solve this, you will going to get Re external dash as 116 milliohm. So, the correct answer for this question is 116. Got the point? Any doubt? Anybody is having any doubt in this question? Please do let me know. Clear? Okay. Let us move on to the next problem, which is this. It is related to the single phase induction motor. A single phase 230 volt 50 Hz 4 pole induction motor has the following standstill impedances. Main winding Zm equal to 6 plus J4 ohm, auxiliary winding Za equal to 8 plus J6 ohm. The value of the starting capacitor required in microfarad to produce 90% phase difference between the current in main and auxiliary winding will be. So, why it is required to have the 90-degree phase shift? Why it is required to have the 90-degree phase shift? Because single phase induction motor is not a self-starting motor. 3-phase induction motor is a self-starting motor, whereas single phase is not a self-starting motor. इसलिए आपने देखा होगा फैन अभी जैसे if you have switch on the switch of a fan, na, sometimes it is not going to be start. So you will take some kind of stick, scale or comb, so on and so forth, like that. And train में हम usually देखते हैं with a pen. So we will going to give a slight force, and from there onward the motor is going to be start, because that motor is a single phase induction motor. ठीक है? Got the point? So to get the starting torque, we must require the phase difference between the auxiliary and main winding as 90 degree. If this is not 90 degree, na, then single phase induction motor is not going to start. Now how we can make 90 degree? By connecting the capacitor in series with the auxiliary winding. So if you look into the equivalent circuit of the single phase induction motor, this is main winding, and in the main winding we will going to have the auxiliary winding. And here you are having one centrifugal switch, and here you will connect one capacitor, and this is your rotor. This is your rotor. So this is main winding resistance, which is Rm, sorry, this is Xm, no? Xm, this is Rm, this is Xa, this is Ra, and this is Xc. So this value is nothing but Rm plus Jxm, and this is Ra plus Jxa. Any doubt? Clear? So see, when you going to add this Xc, the phase difference between these two current, Im and your Ia, it will become 90 degree. Means the phase angle of Im plus phase angle of Ia, it will become 90 degree, such that motor will become self-start. So tan inverse, what is the angle of Im? Tan inverse imaginary part divided by real part plus tan inverse. See, this is J, this is plus J, and this is minus J, because this is capacitor. So you will going to get XC minus XA divided by RA, and the sum of this angle is 90 degree. Done? Now when you resolve it further, you will directly going to get one expression of XC. XC will be XA plus RA RM by XM. This formula is very important. Means after solving it further, we will going to arrive this expression. And what is XC? XC is 1 by omega C. So we have all the values. So 1 by omega C, omega is 2 pi, F is 50. Capacitor value we need to calculate, which is equal to XA. XA कितना है? 6 plus RA RM by XM. RA RM by XM. So 6 into 8 by 4. 6 into 8 by 4. So this is equal to 6 plus 12, 18, and here 1 upon 100 pi into C. So from here C value is, let me see, 176.84 microfarad. So if you connect this value of capacitor, then the phase difference between the two current becomes 90 degree, and from there onward the torque is going to be happen at the time of starting, and therefore single phase induction motor is going to start. ठीक है? Got the point? Any doubt? Anybody is having any doubt in this question? Please do let me know. Am I clear? Done? Let us move on to the last question of this part 1 or session 1. The equivalent circuit of a single phase, I hope this figure is visible to you. The equivalent circuit of a single phase induction motor is shown in figure, where the parameters are R1 R2 dash equal to XL1 XL2 dash equal to 12 ohm, and XM equal to 240 ohm, and S is the slip. At no load, the motor speed can be approximated to the synchronous speed. The no load lagging power factor of the motor is. So this is what single phase induction motor, and I need to calculate the power factor at no load, where at no load the rotor is rotating at a speed of synchronous. Now as I know that the induction motor and the transformer behaves similar, and I also know that the no load power factor of the transformer is very, very poor. It lies between 0.05 to 0.1 to sometimes 0.2. Definitely it will be below less than, or it will be less than 0.2 or 0.2. Therefore the same concept is applicable for the induction motor. Whatever answer I am going to get na, it will be less than 0.2, 100%, because the operation is under no load, and hence it is said that transformer and induction motor must not be operated under no load, because power factor becomes very, very poor. ठीक है? This is not only true in terms of theory, it is true for the practical scenario as well. Alright, चलो देखो कैसे होगा. So in the question it was given that at no load the speed of the rotor is synchronous speed, ns. Then what is slip value, my friend? Slip is ns minus nr by ns. Now since rotor speed is synchronous speed, can I say slip is equal to 0? Slip is equal to 0. So look at here, R2 dash upon 2s, R2 dash upon 2s. Since s is 0, can I say this particular thing will be infinity. है कि नहीं? It means no current will flow here, or you can say this branch is open circuit. This branch is open circuit. Similarly, here it is R2 dash upon 2 times of 2 minus S. So it will become R2 dash by 4. So when you take this particular concept or value to draw the single phase induction motor equivalent circuit, it will look like this. So let me draw it first. So R1 is 12, this is J12, okay, this is JXM by 2, means 240 by 2, 120. So it will be J120. As I told you, this resistance will be having infinite value. So it will be acting as a open circuit. Next one. This is JXL by 2. कहाँ गया XL? This is J6. Okay. Next, JXM by 2. So this is J120. Next, R2 dash by 4. So R2 dash is 12 divided by 4, 3. And next, JXL dash by 2. So it is J6. And this is the supply voltage, which is having V at an angle 0 degree value. Done. Okay. So let me take the current which is flowing here as I. Now since I need to find the power factor, and power factor is what? Is for electrical parameter, na? And since this is a induction motor, so this thing is your electrical quantity. So the power factor at no load, cos phi, at no load is nothing but cos of angle between voltage and current. है कि नहीं? अरे समझ में आया कि नहीं आया? Cos of angle between voltage and current. What is the voltage? What is the angle of the voltage? 0 degree, na? So cos of 0 degree and I. So you need to calculate only the angle of I. So how we can calculate the angle of I? Simply apply KVL in this loop. So I is equal to V at an angle 0 degree whole divided by, I hope this is clear, na? This is the phase difference between V and I. So since this is 0, so whatever angle for current will be nothing but your power factor angle. Okay. So V at an angle 0, what impedance we are having, or the parameters we are having? 12 plus J12 plus, see, this is open, na? So it no current will flow here, so it is redundant. So J120, next plus, these two are in parallel, so J120 parallel with this series combination 3 plus J6, 3 plus J6. Okay, so let me simplify it. V at an angle 0 degree whole divided by, क्या मिलेगा यहाँ पे? 12 plus J 132 plus, okay, plus, हाँ यहाँ पे बताएं J 120 into 3 plus J6 whole divided by J 120 plus 3 plus J6. So let me use the calculator, just a second, let me find it. So it will be 12 plus 120 j into 3 plus 6 j whole divided by 120 j plus 3 plus 6 j. Okay, so I am getting the value as V divided by, or let me write it directly, 0.00722 V at an angle 83, or sorry, minus 83.9 degree. So when you solve this, you will going to get 0.00722 at an angle minus 83.9 degree, and this is V over here. ठीक है? So क्या angle आ रहा है? What angle we are getting for this I? So angle of I is nothing but your minus 83.9 degree. Substitute this value here in cos phi. Your cos phi is nothing but cos of 83.9. Okay, phase difference लेना है ना? Phase difference means 0 minus of minus 83.9. Voltage का angle, current का angle, phase difference. That is why I have written plus 83.9 degree. So ये कितना आ रहा है? Let me check. Cos of 83.9. It is coming out to be as 0.106 lakh. Why lakh? Because in our circuit we are not having any capacitor. So definitely the current has to be lakh, and it is evident. See, the voltage is at 0 degree and current is at minus 83.9. So current is lagging the voltage. ठीक है? So the correct answer for this question is 0.106. How did you like the question? This was the gate question, I guess. So such kind of silly question you will going to have in your gate exam. So with this we have completed the part 1, and it is better to say that we had covered all the important area or all the important concept related to the transformer and the induction machine. I hope you have enjoyed the part 1 session. Okay, any doubt? Any doubt? Clear? So let me take a few minutes to explain one more time. Okay, so this was the practice problem. Please take a screenshot of it and try it by yourself, and please do answer in the chat box. I will going to see each and every student's answer, and if they are wrong, then I will comment it with a correct answer, and those right, I will appreciate it. Okay, so please take the screenshot and try it by yourself. So let me take a few minutes. This was the live online program, and I had already discussed in the very first, or you can say at the beginning of the class, that what features we are giving in the live online program. It is valid for gate 25 and for gate 20. Means those who are going to give, or those who are going to enroll for gate 25 and gate 26, they will going to have the program features for live online program. And what is that? 800 hours plus of live classes with live interaction, theory book for each and every subject, exercise book for each and every subject, plus 30 plus years of GATE question bank along with video solution. 12 personalized one-to-one mentorship session where students get a chance to interact personally with the faculty, and whatever general doubt they are having, they can ask to the particular faculty. And the online test is 130 plus. See the number of online tests. I think we are the first in the across India to give this much amount of test, okay, in the online test series, I guess. With very important point, with video solution of the mock test and many more. Done. So if you want to counsel yourself, then you can book free counseling session by clicking on the link which is given in the description box, or else you can directly contact by calling on this particular number. Done. And this is the interface of our online or the live class. Okay. And the thing that we had discussed in the part 1, all the question with the PDF and all the things will be shared over the Telegram. For that, you will have to join our Telegram group. Link is already given in the description box, or else you can visit to this ID, Telegram ID. Done. And once you will going to join, these features you are going to get right away. Schedule of the free YouTube lecture PDF, important update related to webinar and seminar, PSU and other government job notification, expert session on important topics, and daily quiz and many more. And mark my word, these particular things are very important, and we have seen a quite change or a good change in a student. Means they are getting benefited from this daily quiz. All right. So I am requesting you to please do join our YouTube channel so that you can get a maximum advantage from our Telegram things. Okay. All right. So with this, let me end the session, and tomorrow will be the part 2, which is the last part, and in that we will going to cover the DC machine and the synchronous machine, which is for EE. And the IN students are also welcome, because they may going to give the maybe the state exam, and in that they may going to have the question from the DC as well as synchronous. All right. So guys, whatever doubt you are having, please do post in the chat box or the comment box. Whenever I get the time, I will going to rectify all your doubt in the chat box itself, on the comment box itself, so that you should not be get fear of your doubts. Okay. Done. All right. So let me end the session, and we will meet on tomorrow with the same time, 5 PM onward to till 8 PM. So bye bye, and take a very good care of your health.